Hello dear students, in this video I will give an introduction to the design data handbook. We will look into the various equations that is given in your data handbook, and after that we will go for the design procedure of the flat belt drive. So in your design data handbook, the equations for the design of flat belt drive is given in the chapter number 14. Chapter number 14, where you can see it is listed under the flexible machine elements. So initially it deals about the flat belt, followed by V belt. You can see it over here, followed by V belt. Then and the last portion it will be dealing with the rope drives, and finally the chain drives. Anyway, the rope drive is not included in our syllabus, so we will be fully focusing on the belt drive, V belt and chain drives. So we can see the basic nomenclatures given out here. A indicates the net area of the rope drive in mm square. B is the width of the belt drive, and all the terminologies is listed here. So if you have got any doubt regarding the unit, kindly refer the index part, because all the equations that is given in this data handbook follow this unit. You need not do any kind of conversions. All the conversions which is required is done, and the corresponding equation is given in the data book. So please don't go for any kind of conversions. Only conversion that you have to do is, while substituting in the equations that is given in your data handbook, make sure that the terminologies has got the same unit as stated in the index. That is the only thing that you should be aware about and you should be clear about. Okay, the initial part gives the angle of contact for the open belt drive, and followed by the angle of contact for the closed belt drive. You have got equations 14.1a and 14.1b. And here, as I have already discussed in the previous class, the open belt drive, closed belt drive is given here, and also the length for the open drives and the closed belt drives are given here. There they are also given an empirical relation for the calculation of center distance, but we are not going for that, because if we go for the empirical relations, definitely we have to cross check, or we have to give justification for the selection. So that is not required for the time being. And this equation is followed by the belt tension ratios, without including the centrifugal tension and with including the centrifugal tensions. Both these equations are given here. Also Brad's formula is also given for the coefficient of friction. Now in the page number 291, if you look, you can see they have given the equations for the centrifugal tensions, and I will explain all these details while explaining the design procedure. Now just go through the various equations and the terms. This is followed by the net pull, effective pull, and all those things, power transmitted. And another important equation that we have to use while designing is the power transmitted per square mm of the belt. This is a very important area where the design is giving much stress here. Power transmitted per unit area, that is given from the equation 14.6a to 14.6d. That is followed by the relationship between the initial tension and the belt tensions. This also equation also I have explained in the previous video. This is given in the equation 14.8. and here also they have separately given the design of pulleys, equations required for the design of pulleys, and followed we have got different types of pulleys, and all those different types of pulleys and the corresponding equations which is required for the design of pulleys is listed here from the in the page number 292 and 293. Okay, now if we move ahead to the tables, we can see, kindly come to the page number 305. There you can see different data given for the belt, leather belt, medium condition, light condition, heavy condition, like that they have given the thickness values. You can use this thickness also. I will explain that while explaining the design procedure. And as I have told, they have given lot number of materials that is used for the belt, oak tan leather, mineral tan leather, canvas, like that they have. Bellata is also listed here, and this table gives you the coefficient of friction of various belt materials. Now 14.2b gives you the values of coefficient of friction corresponding to the iron pulleys, leather belt and iron pulleys. So this table can also be used for selecting the value of coefficient of friction based on the velocity. So this is applicable only if the belt is of leather type and the pulleys are of iron. If you turn the page, this is a table 14.3. This table gives you the value of mu theta. So there is a small correction. This is this first column, or the odd number columns, 1, 3, 5, 7, 9, 11. These columns give you the value of mu theta. It is wrongly printed as mu suffix theta. No, it is not like that. It is mu into theta. I hope you remember the details I have given you in the first video regarding the theta L values. You have to mu theta values. You have to go for the smaller among the mu s theta s or mu L theta L. Smaller value of the larger pulley or the smaller value the smaller pulley. So this values can be directly obtained from this table without doing any kind of calculations. You can directly select this value. Interpolations can also be done if required, but there is no need, because the values of mu theta is given here is of closer range, 0.3, 0.31, 0.32. So there won't be any need for the interpolation. Now if you look here, you can see the allowable tension values per mm width of the belt, that is also given here. We may not be using this particular table, but this is just for your information. Followed by this, you have got number of plies for oak tan leather used is also given here in this table. Correction factors for the center distance is given in the table number 14.7. See, all these tables may not be useful for us for the design, but kindly go through the tables, because you should know what all things are given in your data handbook, what all things are not given in the data handbook. Then only you will be able to take a proper assumption or do the design procedure correctly, without which you may end up in a wrong assumption that is not suggested or suitable for a design. So it is always essential that you should know what all are the contents given in your data handbook, and that is the reason why I am giving you a brief information regarding the data provided in the data book. And another one is the table number 13.9b, thickness of the friction surface, rubber, transmission belt, 3 ply, 4 ply. All these things we have to use, that I will explain later. And the table number 14.10 gives you the tensile strength, and you have got different ply, soft, hard type, different, and they have also given the weight of fabric per square meter. See, this table, this particular column is a very essential column for us, and I will explain that while designing the belt drives. And this is followed by different type of pulleys, number of pulleys and all those things, minimum pulley diameters and all those things are given in the following tables. Nominal diameters of the cast iron and mild steel pulleys, all these things are given there. So if you want to have a standard value for the pulley, definitely you have to go and get it from these tables. So these are some of the tables that is useful for us, and these consist of, from here onwards it goes with the tables for the design of V belt. So this much is needed for us, the design of belt drive. So in the next video I will explain the design procedure for the flat belt drive.